Okay, let's jump straight in.
Let's do it.
We've got our hands on the documentation for the NTI E-STHS-LCDW.
Right. And this thing is, it's a really robust piece of hardware.
It really is.
Yeah.
So our mission for this deep dive is to look past the spec sheet and really understand why it's engineered to be this tough.
This is a very specialized device. It's a dual function sensor, so it's monitoring both temperature and humidity. But I think the most important feature is its visibility and, its sheer reliability in these industrial settings.
Okay, so let's start there with the immediate user view. It seems like it's built for readability.
Totally. It's got this 3-digit LCD display.
But the characters are massive, 2 inches high. That's 50 millimeters.
2 inches is huge. And that's a very deliberate design choice. This unit is meant to be wall-mounted.
Right, with simple keyhole slots.
Yeah, in places like these vast data center aisles or huge mechanical rooms.
So you need to see that reading from 50 feet away, not 3.
Exactly. And the interaction is minimal but smart. You have 2 touch-sensitive buttons.
Mode and light. So mode just swaps between the temperature and humidity readings.
Yep. And the light button just activates an LED backlight for, those poorly lit maintenance areas.
They really built this for pure utility, not complexity.
Right. Now let's move on to performance, because the reliability of the actual reading is what matters most.
The numbers.
The operational boundaries are pretty impressive. We're talking -4 up to 140 degrees Fahrenheit.
And what stands out to you about the humidity? It lists 0 to 90%, but it specifies non-condensing relative humidity.
That's a vital distinction. Non-condensing means the sensor can handle high moisture in the air, but not liquid droplets.
So no SOG or actual condensation forming on the sensor.
Exactly. That would destroy the electronics or, at the very least, completely throw off the accuracy. This sensor has to stay dry.
And that accuracy is razor thin. For temperature, we're talking plus or minus 0.72 degrees Fahrenheit. For anyone listening, why is that specific fractional accuracy so crucial?
Well, that kind of tight tolerance often points directly to regulatory needs or high-value applications.
Like that.
If you're storing critical pharmaceuticals, sensitive electronics, or server racks, that 0.72-degree difference might be the boundary between being in compliance and having a catastrophic failure.
So let's talk connectivity. How does this precision instrument talk to the larger world?
It's designed to interface directly with NTI's EnviroMUX systems, which, by the way, also power the unit.
And it just uses standard CT5 or CT6 cable.
That's right. Good for about 150 feet. But this is where it gets unique, how far they push that copper.
They can stretch the cable lengths up to 1,000 feet. That's massive for a monitoring cable run. But the docks note a real constraint there, don't they?
It does. Over that long distance, you're going to face voltage drop. So what's fascinating here is the trade-off they made.
Okay.
When you activate the light button to illuminate the display, the power draw is just enough to prevent the mode button's signal from registering.
So you can have the light on, or you can change the mode, but not at the same time from that distance.
Exactly. It shows you the real engineering choices they had to make for long-distance signaling.
That's a great insight into the system constraints. And if 1,000 feet still isn't enough,
Then you jump straight to fiber optics. They have an EFSC fiber converter that can extend the sensor up to 1.2 miles.
wow, 2 kilometers.
It really speaks to distributed monitoring across a vast campus. And to really cement that idea of it being institutional grade, just look at the reliability.
The MTBF, mean time between failures.
The number's almost absurd. It's listed at 3,491,762 hours.
Okay, let's translate that. That is over 400 years of expected continuous operation.
400 years, yeah.
So this isn't just reliable, it's practically permanent infrastructure.
That's a great way to put it. So what does this all mean? We have a robust, highly accurate sensor built for readability at a distance.
And designed to communicate reliably across extremely large physical footprints. It's a sensor designed to survive. And one final detail that ties it all together, the device is KEA compliant.
Which means it meets the requirements of the U.S. Trade Agreements Act, so it's suitable for government procurement defense-related infrastructure.
So considering that TAA compliance and that 400-year MTBF guarantee, it raises an important question for you listening.
What kind of critical, high-reliability infrastructure where the cost of a 3-degree fluctuation is just astronomical do you think relies on this kind of incredibly robust long-distance sensor monitoring? Think about all those layers of reliability they've baked in.